this can be written as, when we have to find out the derivative of fx, what we will do, we will use this notation, and in this notation we can easily find out its derivative. So it will be transpose of G conical product with In and f plus, when we have to find out derivative of this one, we will use this expression. It will be like int conical with fx and derivative of this one. So this is the product rule we are going to use. For example, if we have to find out vec of the derivative of this one, then we have to use this product rule. Here, this is my fx, this is the gx. Just we'll plug in the value and we will get it. Find out the derivative, I am converting it to dvec ata over d. This is the first step, convert it to vec. Then you can write ata as, you just multiply it by in here and in here, assuming this is m by n. In the first step, you can use these three things, and in these three things, you can convert it as A transpose cross product with in, conical product with in, and vec. Okay, but vec, if you remember, we can convert AT multiplied by and convert it to P by. If you remember, this T was PMN was a multiplexing matrices which was just rearranging the, because A is and this is the first part in which we can find out the derivative of A. And because there are two vectors in this one, A transpose and A, we have to take the derivative of both. So one by one when we will do, so we have to take the derivative of A, we will use this expression. And to find out the derivative of A transpose, I am going to use these three together, and I am going to write it as A transpose And vec AT, I told you earlier, basically vector, what is vec? Vec is putting everything in one column. And to convert AT into A, I am going to multiply it by TMN. Convert this one. If you remember, vec A can be converted into vec A transpose by multiplying 9 by 8. This is a matrix with 0 and 1 only, which is just going to rearrange its rows. So this is converted into TNN, and now we are ready to differentiate. We will differentiate these one by one, and we will get the term. Let us start using this one. Differentiating this, we will get unit matrix here, and this will remain same. This derivative will be 1 or unit matrix, and then we'll differentiate this one. We will get you want to know what is this?
No, I mean that's to be
Actually, every time you have to take care means it depends upon what is the size of this one. According to that, you have to convert it. So if it is this Mn, I think this should be Tnn in my opinion, because when you are converting it, yeah, you have it. Because vec A is, if it is m into n, it will come here, all the points come here in a single row. The number of elements will be mn. So for that thing, we have to take this row as m. I did a mistake. This will come here. And the derivative of vec A will again become 1. I think, is it clear? Now we can manipulate it like into different matrices form as I done here. But this is the basic how we will find the derivative of a product of two matrices. So just let me revise the thing. If we have to find out the derivative of these two things, we will use product rule like this one. And in product rule, one is fx, another is gx, or one is function number 1, another is function number 2. And when there are two functions, we will convert into vector form. We will use vec operator, and when you will use vec operator, it will be converted. It will be easily differentiated. Okay. If we have to find out the inverse, suppose we have to find out the derivative of inverse matrix. I use the same formula of product. I use the product rule here, and we got the result. I think if you want, I can post with everything because there is no time. No more time, is 2-3 minutes more. This is the last proof I have done. I have put some formulas. There are some formulas, and we'll just read. These are all the formulas I have put.